All right, today we are learning how to add and subtract complex numbers. So first thing, adding and subtracting complex numbers, the procedure is you should reduce the radicals if you can. Add or subtract like radicals and put in a plus bi form. That's the process. So let's do a few of these so you can see how it's done. All right, so first step, reduce the radicals. So I've got radical 36 here. So the square root of 36 is 6. It is a perfect square. Nice. And then 2 times negative radical 64. So the first thing when you have negative, make it an I. And the square root of 64 is 8. So it is 2i times 8. And so that it's plus 16i. Next thing, we have 2 times the square root of 49. So 2 times 7. So that would be 14. Change that. The square root of 25 is 5. Okay, so now that we have reduced these, now we're going to combine like terms. So you can just combine like terms. You can line them up like I like to do when I am doing any polynomial function. So I'll just line these up. And we wind up getting 20 plus 11i. Okay, this is already an a plus bi form. So we're good. Next example here. Alright, so I'll leave a little more space here. The square root of 16 is 4. And then we reduce this one. So it would be 2i times 9. So this one particular binomial reduced is 4 plus 18i. Alright, now we're going to subtract 10. There we go. Minus 2i. Alright, so that one's totally done there. Now this is a subtraction problem, so remember this one stays the same. And this is like a negative 1, we're distributing in. So it's negative 10 plus 2i, and then we just combine nice like terms. Negative 6 plus 20i. So what you'll notice is you're combining like terms here, just like i's were x's. And that's really all it is. You're just counting how many you have. So here I have 18, here I have 2, so together I have 20 i's. That's it. That's all there is to it. Okay, this one's pretty straightforward. 2 minus 4i. This is addition, so I'm just going to keep the signs the same. Combine like terms. And this one is already in a plus bi form. Good for us. So this is just a subtraction problem. So remember, if you like to think of it that way, you've got to distribute in. So it's 2 plus 3i minus 5 plus 7i. Combining like terms, negative 3 plus 10i. Okay, this one might not be the same as yours, but just make it so it is. Alrighty. So we got to reduce these. So this would be 4i minus, there's 64. So again, that's 8i. Now this one is not a perfect square, so I need to reduce it. So perfect square is 9, not perfect square is 2. So this would be 4i minus 8i plus 3i radical 2. Right, this 3i radical 2 is a unit. That unit cannot be broken up. But these two are like terms, so I can combine them. So it's negative 4i plus 3i radical 2. This one in particular is a little difficult to put in a plus bi form because there's 2 terms and we can't combine them. So sometimes what we do is we do factor out the I. So if I take this I out, basically divide by I. We usually put the I on the end. You could put it on either side, but a plus bi form. A would be 0, this would be b, this whole mess, and that would be I. Pretty crazy, but that's just the way it is. Alright, so let us do this one. Another example. So square root of 32, we do need to reduce. None of these are perfect squares, so I do need to reduce them. So this has a negative on the outside, not on the inside, so this has no I. So I'm simply just reducing 16 and 2. So this would be minus 4 radical 2. So please be careful with that. Once I've taken the square root does go away, and that 4 is done. Alrighty. So the negative was under the radical here, so find the largest perfect square that goes into 72. That would be 36. And so this would be plus 6i radical 2. Now here, finally the last one. Then we have an I, and then we have a 4 and a 2. So it would be minus 2i radical 2. Okay, now we can only combine like terms. This one does not have an I, but they do all have radical 2s. So you have to look at the radical and make sure all the radicals are the same. That's the only way you can combine them. But you also need the same I. So here has an I, this one has an I, so these two can be combined. This one cannot. So this stays negative 4 radical 2. This one here can be combined, so we're counting how many I radical 2s there are. So it's 6 there, minus 2, so it's just plus 4i radical 2. So all we're doing here is combining the 6 and the negative 2, just like if that was like 6xy minus 2xy. You got to think of it like that. The x would be the I part, and the y would be the radical part. They do always, everything has to match there. I don't know if that helps, but you know, it's what I got. Alright, now we have graphing these, so you already know how to graph. You just have to add them and then graph. Just, you know, whatever. See how it goes. Here we go. So graph the following. So I'm going to graph 2 plus 4i, so there's 2. 1, 2, 3, 4. So that's 2 plus 4i. That's a 4. And then negative 1 minus 3i. Negative 1 minus 3. So this is negative 1 minus 3i. So if we want to graph their sum, all we're going to do is add these guys together. So 2 plus a negative 1 is 1, and plus 1i. So here we are, 1 plus 1i. Let's change colors just for ease of... So it would be right there. This would be 1 plus 1i, or 1 plus I is the same thing there. What quadrant is the sum in? Well, this is quadrant 1, this is quadrant 2, this is quadrant 3, and this is quadrant 4. I always say they go in a giant C for your memory purposes. And this answer is in quadrant 1. Alrighty, have a wonderful day.